Hello everyone. The purpose of this talk is to provide people, especially penetration testers, an overview of what a blockchain is, how we can look at it from a security perspective, what kind of tools are available to conduct engagements, and overall get a general understanding of this new technology that no doubt will be a major player in our field over the coming years. First off, let's begin by discussing what a blockchain is. In terms of definition, a blockchain is quite simply a database. And you can think of it much like how you thought of it in your previous engagement, in your web engagement, especially when you were faced with a web application that had a backend of MySQL or MS SQL or Oracle. A lot of applications that are built on top of the blockchains are much like that. They're usually a web interface with a backend database that's built on top of the blockchain. So the blockchain itself is simply a database, but its format, the way it operates, it's slightly different. In terms of features, databases have features that are different from what traditional databases offer, which I will describe in detail. So with traditional databases like the MS SQL, MySQL, Oracle, everything was and still is centralized, meaning that there is a server somewhere, and that server is hosted by the company that needs the database to operate for them, or that server is somewhere on a remote data center somewhere, but it's still owned and operated by the company that owns it. With a blockchain-based database, the game is shifted. What we see is a database that is hosted by multiple parties, which are usually untrusted, so they don't really know each other. They have no particular relationship with each other. They just want to operate the blockchain. They just want to operate the database. So what happens is each one of those parties will grab a copy of the database and help each other maintain the latest state of that database, and in the process they get rewarded. Now with traditional databases, we have a permissioned way of approaching objects, meaning that if you were to read or want to read something from the database, you need to have some sort of permission. You have to have maybe read permission or write permission in order to do anything on the databases that are traditional. However, with blockchain-based databases, everything is permissionless. What does that mean? It means that anyone at any moment in time with public blockchains can go and read everything on the database. Every single piece of information on the blockchain, especially public blockchains, are public. I say public blockchains because some blockchains are private. You can have a group of people that would operate a private blockchain, and they can try to keep its information private. But most of the industry right now is full of public blockchains. So just keep in mind that with blockchains, people can read all the information. There's no need for you to have any permission at all. You can just go to blockchain reader services and just read any particular transaction or information. And finally, with traditional databases, administrators can modify records. Let's say you accidentally put some incorrect record on the database. You can contact the administrator of your organization and ask them to remove the record or change it or modify it. With a blockchain database, that is simply cannot be done. You really cannot change anything whatsoever. Once you do it, once you write something to the blockchain, it's there forever. And that's basically the difference between traditional databases and blockchain-based databases. Traditional databases have their use, and they will not go away, but blockchain databases add a new use case, allow for a new form of application slash protocol to be built on the internet that previously wasn't possible. So that brings us quite nicely to Bitcoin, and what is Bitcoin, and how can we use it for our own benefit and understanding of what blockchain is. So Bitcoin is basically a peer-to-peer cash, a currency that has been built on top of the blockchain. It's basically an app. Think of it like an app that's been built on top of the blockchain, and you are able to, as an individual, to transact this currency between yourself and a bunch of other people. There is no bank that's operating it. A group of untrusted individuals, people that don't know each other, are operating the Bitcoin network, and using the blockchain technology, they keep it up to date, and they do the transactions, but in the process, every time the people who are operating the network make a transaction happen, they earn a small amount of fee, and that's how the network keeps running. That's how we can continue using Bitcoin without the need of any central government/company. In terms of features, as I mentioned, it's decentralized. There is no organization that operates Bitcoin. It's a group of people that don't know each other, but they have found a cryptographic way to confirm transactions are happening without being forged, so they can trust each other and transact in that way. Everything on the Bitcoin blockchain is public, meaning that everyone can read every single transaction, and everything is immutable, meaning that if I had one Bitcoin, I cannot send it to two people, and this is only possible because of the blockchain technology. With blockchain technology, you cannot duplicate your Bitcoin and send it to two people at the same time. It's cryptographically impossible. So that's basically Bitcoin is a product of the blockchain. You just keep that in mind. It wasn't possible in the old traditional databases, but it is possible. And this is one of the many things that could be built on top of the blockchain. Now, Bitcoin has limitations. Think speed, think scripting capability. What does that mean? So once you use Bitcoin, you'll notice that it is slow, meaning that if I was to send you a Bitcoin right now, it will take you probably 30 minutes. Sometimes it's earlier, sometimes it's slightly later, but on average 30 minutes before you get a confirmation that yes, it has been received in your wallet and you have received the Bitcoin. That's a problem, because if you want to build something on top of the Bitcoin blockchain, it will take quite a while for it to actually propagate and finish. So that's quite limiting. And there's also a problem with scripting capability, meaning that if you wanted to utilize the existing network of Bitcoin operators, the existing Bitcoin blockchain, and build on top of that instead of rolling your own blockchain and then finding people to operate it and slowly grow, just build on top of Bitcoin instead. If you want to do that, the scripting capabilities of Bitcoin are very limited, so your hands are quite tight over there. So what was the solution to this problem? The solution was something called Ethereum. Ethereum was proposed by a gentleman by the name of Vitalik Buterin back in 2014. His proposal was this cryptocurrency is incredible, the Bitcoin cryptocurrency, and you know what we can do, we can use it, expand it, and make it even better. So how about we increase its speed? How about we make a lot of modifications to it? And he wrote an extensive proposition and presented it to Bitcoin developers. And at the time, Bitcoin developers passed, saying that these are what Vitalik was proposing were major changes to what the Bitcoin ideals were. So they passed on those proposals. And that's how Ethereum was born. As I mentioned, Ethereum is an open source blockchain. Everyone and anyone can build on top of the Ethereum blockchain. And in order for you to build on top of the Ethereum blockchain, what you need is something called Ether. Ether is the cryptocurrency used to perform any actions on top of the Ethereum blockchain. Much like the Bitcoin sort of system and blockchain, it's decentralized, it's public, and it's immutable. So a large number of people across the globe are operating this blockchain network. Everybody can read every transaction, and nothing can be changed or forged on the Ethereum blockchain. Now, in terms of limitations, there are two problems with the Ethereum blockchain. One is gas fees, and the other is speed. Now, you might be asking, what is a gas fee? If I wanted to perform a transaction on the Ethereum blockchain, let's say I wanted to send some Ethereum from point A to point B, there are some fees, and those fees are called gas fees. And those fees will incur regardless of what the price of Ethereum is. They are mandatory for every transaction. And if you were to think of them, they are denominated in Ethereum. So if the price of Ethereum goes to 10K or 20K, that fee is fixed. So you will still be, in terms of Ether, you will be paying the same amount, but in dollar value, the fee could be much higher or much lower depending on the price of Ethereum that day. And that presents some problems, because if you were to build on top of the Ethereum blockchain, then your application would need to perform some transactions, maybe move Ethereum from point A to point B for whatever reason. The fee that you or your users should pay increases drastically depending, or decreases drastically depending on what the price of Ether is that day. Now, another famous keyword you hear in this industry is dapps. What are dapps? And I think this diagram really explains it quite simply. Dapps are decentralized applications. Any application that has been built on top of a blockchain-based database is called a dapp. And that's all that it is. You hear it being thrown around all the time, and really the easiest way to think about it is this: an application on top of the blockchain. Now, as penetration testers, what we will be faced with when we are, hopefully in the future or in the near future, will be doing blockchain-based security audits, is that people will provide us a web interface, a web page, and with that, on that web page, there will be a login mechanism. You would go and test that login mechanism, and you would log in, and then what you're presented with is quite simply a web application initially that could suffer from all the typical issues that a normal web application suffers from. So if you are going to conduct that engagement, for the first part of it, you would have to just use the normal OWASP methodology on the web interface to see what you could find and then report on those. However, with blockchain security audits, there's a second part to this puzzle, and that's actually doing the code review. Every single logic that has been written is written in a language called Solidity on Ethereum. Now, with Solidity, the language is much similar to JavaScript. If you have done JavaScript before in the past, it would be easy for you to pick up Solidity. And you can use Solidity to create the logic necessary to do all the operations needed on a blockchain database, which in this case with Solidity, it's Ethereum. So with every engagement, you get two parts. One is doing the web interface with the OWASP methodology, and the other is learning Solidity and then trying to pick up common code patterns that are bad and point them to the developers with a white box engagements. And to learn what are common bad practices, people in the Ethereum community have put in a fantastic registry of classifications in place on a website that you see on the screen, swcregistry.io. On this swcregistry.io, you will see a page that presents 36 different classifications of different types of bugs and how you can look for them, how you can fix them, what is the implications of each one. So hopefully once you learn Solidity, your next step should be to browse this page and pick up what are the important skills necessary in order to understand what code could be vulnerable and then report it accordingly. Now, I wanted to walk you through how the code looks like and then give you a couple of examples and show you how simple it is really to understand the language, and then what kind of bugs could be found and how bad or good, well, how bad they can be really. So, what you see in this page is the most basic Solidity code you would see out there. The first line is just a compiler version. You're basically telling the compiler which version to use to compile your code. And then every single application that's been built on Ethereum, at least, it starts with the line contract. And what you see here is the name of the contract afterwards. So it's contract hello world. That's on line 3, that's just the contract name. And then on line 4, we just define a string variable and we give it a value of hello world. That's all that it is. And once you compile it and then call the greet variable, you will see the hello world being printed. That's all that it is really. Now, I want to give you a sample vulnerable code. If you have done any sort of white box testing of code before, I'm sure you're very familiar with overflows and underflows, meaning that if a value goes over a certain threshold, it goes back to its original value instead. So in order to give you an example, what you see on this page is, this is a contract called withdrawal. If you look at line number 2, contract withdrawal, that's just a contract name. On line number 3, we have an unsigned integer that is for the balance variable. So the balance variable has been or has a type of unsigned integer 8, meaning that the maximum value it could have is 255. So the problem here is that if someone was able to increase their balance to more than 255, suddenly their balance changes to 1 because it rolls over, the variable unsigned integer, it rolls over once it hits its maximum value back to 1. And another way to exploit this issue is if someone was able to withdraw a sum more than their balance, make sure the variable goes back to its max value, then they can abuse it that way as well. And this is the issue that you see on the screen. So on line 4, function withdraw, unsigned integer 8, sum. So what you see here is there's a function that is for withdrawing, and the sum variable is of the type unsigned integer 8. The sum is controlled by any user, so what they can do is they can provide a number, for example 2 here, or 3, and in the next line, on line 5, the balance, the sum is subtracted from the balance, so number 3 is subtracted from 1, which is the balance, and because the variable has a maximum value of 255, so it's 1 to 255, and when you do the subtraction, it goes back all the way up to the maximum value. And you artificially increase the value of your balance because of this underflow issue. Another issue, another vulnerability within Solidity is what you see on the screen. The answer is really inside the note that I provided at the top. So in Solidity, you can create functions, and you can set functions to be public or private. And if you forget to properly secure them, anyone can call them later. What you see now is the code itself. So you see Pragma Solidity 0.4.24, that's the compiler version. The next line is contract identity crisis, that's a contract name. The next line afterwards is address public owner. It's just a variable of the type address that holds the address of the owner. And then we have a function called set wallet owner, and it takes any address that the user provides and is set to public. And this is exactly where the problem is. If you create a function and you set it to public and you forget to secure it with other means that Solidity provides, people can later call it again, make themselves the owner, and then take over the contract and become the owner, and then probably withdraw its balance if it has any balance. This exact issue was the source of multiple exploits as of recent, where people created some sort of function that would do something incredibly sensitive, but they forget to set it or protect it properly, and that caused all sorts of issues. And that's really how to look at Solidity. As you can see, it's a very, in my opinion, if you know JavaScript, it's a very simple language to read. You just have to have the patience to go over it. Once you do the web interface checks, you just get access to the code, go over the code, but you have to also understand what to look for, so the SWC registry is the best way to approach this. Now, in terms of tools, there are 2 excellent tools out there. One is Slither, is the one I use all the time, and Slither is a free tool, and what you do is you just point it to some piece of code that you have received from the client, and you let it run. It gives you an incredible number of results. However, a lot of them can be false positives, so it's up to you as the reviewer to go through the results. Use Slither as a starting point to understand, okay, there might be an issue on point A or point B. Maybe I should start looking there, and then sort of start filtering down what is valid and what is invalid, and then take it from there. Mythics is also another good service. It's paid, however, but it's also another good service that does reviewing of Solidity code as well. And with that, thank you very much.